Direct and inverse variation. Direct variation is when the quotient of variables is constant. So if you'll remember that the constant is k and quotient is division, so k equals y over x. If we solve this equation for y, we multiply x on both sides, and we get y equals x times k, and then cleaning that up a little bit, we get what we're more familiar with, which is y equals k times x. So what we have here is this equation, k equals y over x, helps us to find the value of k, and y equals k times x helps us to get the equation itself. Inverse variation, on the other hand, is when the product of variables is constant. So for the product to be constant, that would mean k equals y times x. So now if we take that equation, k equals y times x, and we solve for y, we divide both sides by x, and we get y equals k over x. And again, this is the equation that the one that has y equals is always the equation. And then the one that has k equals is always the way that helps us to find the value of k. So in this case, we are being asked to tell whether the set of ordered pairs represents a direct variation, inverse variation, or neither. So remember that direct, from right before, is when the constant, or when the quotient is always constant, and inverse is where the product is always constant. So to tell whether they're direct, inverse, or neither, we just have to check that. So I'm going to start with direct, especially looking at part A, looking at these sets of ordered pairs. The x value is always smaller than the y value, so this kind of makes sense that maybe division could help us. So on the first set of ordered pairs, or the first ordered pair, k equals negative 14 over 2, which is negative 7. If all the other ones equal negative 7, then we're okay, and it's direct. If not, then we can check something else. So I do y over x, which is negative 7, and then the last one, I do y over x, which is negative 7. So because those are all the same, it tells us that they're constant, and that is direct. The next one, my y and my x just kind of vary. Notice these two ordered pairs have the same exact coordinates, just flipped. So direct is probably out of the question because division is going to be different. But I can try my inverse, and if not inverse, then I can go back and try direct. And if neither, then it's neither. So I multiply for inverse, and I get 24 for the first ordered pair. I can already tell that I'm going to get 24 for the second ordered pair because it's the same exact two numbers. And then the last ordered pair, I'm also going to get 24. So this is inverse. So we're going to write an equation for direct variation that includes the point 618. So remember, k equals y over x will get you the constant, and y equals kx gets us the equation where we just plug in the k value. So we get the k value, k equals 18 over 6, which is 3. So our k value is 3. Now we just plug that into our equation. So y equals, plug in 3 for k, x, and that is the equation that they were asking for in this problem. Now we need to write an equation for inverse variation that includes the point 4, negative 7. So remember, k equals y times x gets us the constant, and y equals k over x gets us the equation. So k equals 4 times negative 7, which is negative 28. That is the constant that gets plugged in right here. Again, y and x remain variables, so y equals negative 28 divided by x, and that is the equation that we were asked for in the problem.
Made with Doodlecast Pro.